Hello, in this video, we will talk about expected value of sums of random variables. So we know the expected value or the mean value of a random variable or the random variable's function can be expressed as this way. For example, this is a discrete random variable for x and y. So if we know the joint probability functions for x and y, then the expression of a random variable of x and y, gxy's expected value, can be expressed as the summation across x and y different values. Then this expression times the probability of these joint variables x and y, right? But this is a discrete case, and for the continuous case, we know the probability density function of x and y, or this is a joint probability density function. Then we can get the integrals along x and y sequentially with this expression gx and y. So this is the mean value, the expectations of a random variable or the expression of functions of random variables. Then if this random variable's function gxy is x plus y, so the case is x plus y, then times the density function of x and y. Then we take integral over x and y. So we can get if we divide this expression as two parts into integrals process. So the first part and the second part equals to ex and ey individually, right? So this means the mean value of x plus y can be expressed as the mean value of x plus mean value of y, right? And this applies to more than two variables summation. So we ex plus ey and ez, right? So this is quite easy, and we do not need to know the distribution of x and y. They have not been independent or not independent. So x and y can be not independent. They have covariance not equal to 0. It's no problem. We just use this expression ex plus y equals ex plus ey. Quite simple, right? Next, we take a look at two examples. First example is quite easy. So what's the expected value of the sum obtained when two fair dice are rolled? So we roll these two dice, and each row of two dice will get the number of summation of two dice number. So for example, the first dice gets a 3, second dice get a 2, so we get the sum of these two dice is 5, right? And we want to know the expected value of this summation. So because two dice summation, the number can be at least 2 and no larger than 12, right? So if we want to calculate the expectation manually for each value of x and each probability of x equals I, then we can get the summation I times probability if probability x equals to I, right? Then from 2 to 12. But this expression may be difficult because we want to calculate the probability. These times complicate. But if we use the expectation of the summation of two variables, then expectation of x equals the expectation of x1 plus expectation of x2, where x1 and x2 are number or the values of dice 1 and dice 2, right? So this one will be much easier because each dice will have the expectation 3.5. So we just get the summation of two of these, and we'll get 7 for the summation of two dice as the expected value. And the second example is, suppose we have different 20 different types of coupons, and suppose that each time one obtains a coupon, it is equally likely to be any one of these types. Then the question is compute the expected number of different types that are contained in a set for 10 coupons. So we have total 20 different types of coupons. For example, X1, X2, and X3. These are 20 different types to X20. And another number is 10. What is 10? So we now get 10 coupons from these 20. And we want to know the expected number of different types. Here is the question is different types. So what means different types of 10 coupons? For example, if we have 10 coupons and 5 are coupon 1 from these 20, and 3 are coupon 2 from these 20, and 2 are coupon 3 from these 20. So this different types number is 3 in these 10 coupons, right? So no matter how many number of one kind of coupon in these 10 coupons, we just count 1 for this type of coupon. So we want to know the expected number of different types of coupons in these 10 coupons. It's quite complicated in the first glance. So, but this question can be thought of as the expected number equals the summation of x1, x2, x20. If we take x1, x2, x20 as a Boolean variable. Boolean variable is 1 or 0, right? Or binary variable 1 is 0. So if at least one of these type of coupon is contained in the set of 10 coupons, then we say this xi is 1. So in the last example, we see we have coupon 1, 5, coupon 2, 3, coupon 3, 2. So here xi, x1, x2, x3 are 1, but x4 to x20 are 0, right? So we can model this summation or expected number of these different types of coupon in this 10 is the summation of these 20 random numbers. And each of these 20 random numbers can be expressed as a Boolean or binary result 1 if at least of this type of coupon in a set of 10, right? Otherwise it's 0. Then because these 10 or 20 coupons will occur independently and they have equal probability can be chosen. So which means we can add this EI equals, so which EX equals E1 to E20 summation. So we just calculate the expectation of each EI, then sum together for 20 or times 20. Then we can get a final number. We just now calculate the expected number of each coupon in these 10 coupons, right? So expected number if it equals the probability of xi equals 1 can be calculated as 1 minus probability of xi equals 0, right? So because x can take 2 values, so the probability of 1 is 1 minus the probability of 0. And the probability of 0 can be calculated probability of 0 is 20 of 19, 10 power, right? Because each time select one coupon, if this coupon is selected, what's the probability for each time is 1 of 20, right? So the probability of not to be selected for this coupon is 19 of 20. So we have time together 10 times. So 10 times, select 10 times, and this coupon not be selected each time is 19 of 20 with a power of 10. So this is the probability of this coupon not selected, or the probability of this number is 0. So 1 minus this probability is the probability of this coupon be selected at least one time. Then we use 20 times this probability and get the final number is about 8.025. So the expected number of how many different types of coupon in this set of 10 coupons is about 8 different types. Thanks for watching.